right. So, but as far as for the graphing, and you guys can tell me, and we won't have to do a lot of this if this is as easy to you as it is to me. Like I said, I really prefer it this way because it's a lot easier not to get mixed up. So color coded like last time in our class where I was saying like this would be function 1, function 2, function 3 in our list, just like as if it was written out in an equation. But when it says like g of 1, so that means x is 1, because remember this is g of x, and we've just subbed in a 1 for x. Algebraically, you plugged that in. Here, you're going to go look at 1, and then you're going to go find up and down where the function is. And so in this case, it goes up, and so your answer is 5. And that's literally it. So g of -3, -3, if I go up, there's nothing. But if I go down, it's right here, and then I go find my y value, which is a -1. G of +3, you're looking up, there it is, so there's nothing down. Go back and find my y value, which is 5. G of +5, come all the way over to +5. Again, you're looking up and down. There's nothing up, so it's down, and then we go find our y value, which is -3. So it's sort of like thinking about the coordinate of what this is. So it gave me 5, so I know that's my x value. What is my y value is another way maybe to say it in case I'm not saying it where it makes sense. So +4, in this case, there is a function up here, but that is that open circle, which means that's a hole, and that's not a place you can stand. That's not a thing you can use. So we're going to go back down here to the pink one, because that is a solid circle, and so -1 would be the correct answer for that one. Math 3 EOC-wise and Math 3 testing-wise, I haven't seen them do the graphing much different than this. But when we had the functions last week that we talked about, like f of 2 plus f of 4 minus 2 times f of 3, and I just used f out of habit. But if we were to pretend like it was g, you could still do this process to do these equations. And that's what I was saying as far as Desmos. So if you get the algebraic set, like the 3 set or whatever set you get, you can actually graph it in Desmos. So then it's as simple as this graph with these and then just plugging it in, if the graphically makes more sense to you. So let's see if I can switch my screens. I can't. I'm going to do it at the end and show you so I don't lose all this and have to reset all this thing, because this program's not super easy to reset, or it doesn't do what I want it to do. So your other side of graphing, does anyone have a major question on that, or is that as straightforward as sort of I think it is?
This segment,
yeah.
I'm still struggling with the graphing a little bit.
Okay. All right, so then I will do more of this on the next one above it. It's a different question, but I'm going to do some more anyway. And if you have a specific, like something I can clarify, like, oh, where did that come from, or why did that come? Why did you do that? Ask me. Because unfortunately, the things that I find really easy, if I haven't gotten to communicate a lot with you guys and no one's reaching out to me, I don't know what to say to make it better and not worse. So this would be a multiple choice style question. So there's one here and one here. So matching the graphs to the function. If you were in a classroom, some of the honors classes and some of the Math 3 teachers that like to graph in general, or just math teachers that like having students to graph, you would have to actually put these functions on a graph. To be honest, virtually that doesn't even make sense, because you have a Desmos, you have a TI-83 or 84, you have tons of opportunities to be able to do it virtually or digitally without having to put a pencil to a piece of paper, which is fine because your EOC is not on paper either. So obviously you're not going to really have to graph on paper. But things you need to make sure you understand is that equal to is going to be a solid circle. The lack of an equal to is going to always be an open circle. The reason we went over parent functions is because knowing that this is a radical function, so you know that it's going to look like some version of that. A single number, so y equals 3, means it's definitely going to be a horizontal line when it's a single number. Oops, I'm not on the screen, sorry. Horizontal line. And then, so like looking at this one, this is an x squared, so we know that it's going to be some portion of a parabola. That's a negative x plus 3. So again, we know it's going to be a negative line, but it's just going to be cut into parts because we're only looking at certain windows for the domain. So knowing that this is 3, so it's a horizontal line, if you're looking at your multiple choice, and test skills, I know people get really, really huffy when teachers teach to a test or teach to a question, but let's be honest, there's no reason why you should like even remotely look at this guy. Like you should cross one out, make your life better. Not knowing it's not the answer is just as helpful as knowing if it is the answer. So this is an absolute value in a quadratic, if you can see it. So that's your u, and there's your upside down v. Neither of those two types of functions are up here. So that is definitely an out. Don't do that one. So we have our little not very curvy radical, horizontal line. All 3 of these horizontal lines are at 3, which means all 3 of these are good as far as that first function. Then your second one is your radical function moved down, but it's only from +1 over. So it's a little harder to visualize, but you can test coordinates if you want. And in this case, the first one, it looks like that might even be a real coordinate, would be your 8, which is a little hard to see because I clipped it. Sorry. So 8. These are 8s because they're going by 2s. And actually, as I'm saying this, let me look at one thing real quick. Oh. Make sure I'm not telling you a story because that would be a mess. And then you would just look through. Other ways, because this is a equal to, we know that that has to be a solid circle at +1. At +1, that horizontal line here is an open circle, and that horizontal line here is an open circle. So without doing any major math, just knowing how inequalities are graphed, and then basic parent functions, this one is gone, this one is gone, this one is gone, and you really did no math. Does that make sense, what I just did? For your logic, hopefully.
A little bit.
Okay, we'll go to the next one. Same idea. So looking at the functions, like I said, so this is a quadratic. This is going to be linear. It's a negative line, so we know it's going to be facing in this direction. So we definitely don't want it. Like in this case, this is a positive line. This is a quadratic, but this is a positive line. So that's not going to be this line because it is negative x since it's linear. So that one's definitely out because of that. We have an equal to here, which means we know this is going to be a solid circle. We don't have an equal to here, so we know that's going to be an open circle. So our linear portion, which would be like this is a horizontal line, has to have an open circle. All 3 of these do have an open circle. Really, you could stop your conversation there, maybe if your brain works this way, because this is not y equals -2 or +4. So this horizontal line, this is y equals -2. This is y equals 4 because it's a right-left, just straight line. That's not a linear function. So these guys are now out as well, and you now have B as your correct answer, which is correct. As far as the way these are graphed, so that -3 in there took your parent function and moved it to the right 3. So this is a parent quadratic moved to the right 3, which is exactly where it is, which is beautiful. And in theory, it really does continue because it is a quadratic, but we're looking at windows. So that less than or equal to 4 means that that quadratic, so like this first function, only exists on this side of the graph. And it only, the other one, because it says, that's not highlighter, is greater than 4. So the linear function is only going to exist from 4 to the right. So that would be another way you could start sort of getting rid of some answers and helping to pick the right answer. Let me see if I can find something else that might make that make more sense if it doesn't. Real quick. So this is what I used to do in classroom when I could force you to do the things. So you graphed x plus 2 on a blue grid, and you got a full square. And then you graphed y equals 1, which is that horizontal line here, on a green full cube. And then your pink was going to be your quadratic. And then we looked at our numbers, and we cut from -1 to the left off and threw the other part away because it's not part of our conversation. Then we cut out -1 to +1 in our green one, threw the rest away because it's not part of this piecewise conversation. And then x is greater than So everything bigger than 1, we cut out the pink and threw the other half away and then glued it together. And that's basically what piecewise is in the event that hasn't clicked for you. It is 3 or 2 functions, and we're just looking at little like portions of its existence, depending on what domains they've set. It's probably way better to actually go through the process and cut that bad boy up. And then so how just to sort of go back on this guy. So this is our correct graph. So f of 4, if I go over to 4, so this is 2, 3, 4. The function is up here and down here, but that is an open circle. So I'm going to go up, and it's hard to read, but that is going to be 1 because these are counting by 2s. And then f of 0 means I'm going up and down here. But also you should see with the pink that we know we're looking at this function, and it's going to be 8. Algebraically, f of 0 is less than or equal to 4, not greater than 4. So that 0 is 0 minus 3 squared. Oh, it's 9. It hit after. Sorry, that graph is terrible. I tried to put this on top of this, so that was 100% my fault, not something you should run into otherwise. That was me trying to make questions up without checking them. So 0 minus 3 squared would be negative 3 squared, which gives you that positive 9. Any graph you're going to see on your quiz with me, it will actually like be a thing. I just didn't have enough time to get where it was counting by 1s and things of that nature. If I have to go make them myself in Desmos, they won't be so hard to like kind of guess. It won't be, it's close, but maybe not. It'll be on its place, kind of like the f of 4. And same thing for f of 4. It's equal to 4, so that means 4 minus 3 squared, which is going to give me 1 squared, which is algebraically that 1. So it's 100% up to you which way actually works if you are given both. So the bottom, you don't have the function, so you can't really plug it in. You have to use the graph. If you were to do these over here, so our correct graph, f of 1, so that was 1, go up, and that's at 3. And so you're looking at this coordinate because it's 1, 3. So when x is 1, what is 3? So f of 4, I'm going to go over to 4. It looks like it's about 1 if I cut it back. And if you want to check it and see if I did another one that was absolutely not correct, we absolutely can. So x is greater than 1 would be 4. So we're going to use negative 1 plus the square root of 4, which is 2, plus that negative 1, which is indeed 1. Okay, good. I didn't mess that one up.